All right, now notice this problem here. It says find the length of the arc in the following figure round to the nearest tenth. Now, introducing you to a new idea. It's called radians instead of degrees. Okay. So let me just tell you the relationship here. That 180 degrees, I'm going to write degrees instead of the degree symbol, is equal to pi radians. Right? In picture form, imagine we have a straight angle. So we have a dot here. We have a ray going off to the right. We have a ray going off to the left. How many degrees is that angle?
180.
180 degrees. So I want you in your brain to make this relationship that 180 degrees and pi radians are the same thing. Okay. If I said something was 1 foot long and I said something else was 12 inches long, that means the same thing, right? Same with this. They've invented this dimension called a radian with the relationship that pi radians and 180 degrees are the same amount. So when you see pi in your brain, think straight line. All right? So notice 3 pi over 4, 3/4 of pi, a little bit less than a straight line. If it was 5/4 pi, it would be a little bit more than a straight line. So that's kind of how it works. And if a straight line is 180 and pi is 180, how much would 2 all the way around the circle be? So if I'm here, and from here to here is pi, and I want to go all the way around, how far did I go?
2 pi.
2 pi, right? So from here to here is 1 pi, back to there is another pi, so all the way around the circle is 2 pi. Just as times 2, 360 degrees would be times 2, 2 pi. So a circle has 360 degrees, a circle has 2 pi radians. So those relationships you need to know. And this is the exact same question that the last question was, except this is in terms of pi. Now imagine the same rule, the same formula. So my arc length formula for the other one said a over 360 times 2 pi r. But instead of 360, since we're dealing with radians, I'm going to divide by 2 pi. Right, 2 pi is the same as 360. Take a quick, simple look at this formula here. Again, I made it the same way. I'm not going all the way around, so I'm going some part. So this is A. All the way around is 2 pi. Radians over radians. If I'm in degrees, it's degrees over degrees. 80 degrees over 360 degrees. This is radians over radians, so 2 pi. Notice A over 2 pi times 2 pi r. 2 pi cancels 2 pi. So the arc length formula in this case is going to be AR. It's a very, very simple formula. Again, it's created the exact same way, but there's simplification possibilities there. So if we know the arc length, or I should say if we know the essential angle and we know the radius, we simply multiply those together. So the arc length in this case is going to be 3 pi over 4 times 6. Again, it says round to the nearest tenth. Okay, so 3 times pi times 6 divided by 4. 3 times 3.14 times 6 divided by 4. Always do the divided by last. Okay, when you punch in your calculator, you can do it all at once. So 3 times pi, which is 3.14, times 6 divided by 4 comes out to 14.13. We're round to the nearest tenth, we're going to go 14.1. That's going to be centimeters. And arc length, if they go to the trouble of giving you a unit, put the unit on your answer. All right. If they said leave the answer in terms of pi, notice we're almost there right now. If I just chop the 6 and the 4 down to a 3 and a 2 before I multiply, I get 9 pi over 2 centimeters. And they're going to ask for either an approximate value to some rounded amount, or they're going to ask you for the exact value in pi form. Okay. If they go to the trouble of saying, I want it in this form, make sure you give them that form. If they don't specify, whichever one you prefer is fine with me. So if they say do it this way, I'm gonna have this on my answer key. If they don't specify, I'll have both on my answer key, whichever one you prefer is the one I'll grade. So that's how to do that.